you probably have seen functions or been exposed to the word, but maybe you never really understood what it meant. So this section we're going to talk about what a function is compared to a relation, and then also talk about domain, what domain of functions are. Okay, so any table that I fill in an x and y, that's called a relation. It's a relationship between x and y. Okay? Functions are specific kinds of relations. Okay? They're not every relation is a function, because relations have, or every relationship there is with x and y, there's specific relationships that are called functions. And function notation, you've probably seen this before, looks like that. It could be g of x, h of x, it could be f of t, doesn't matter. This is just a fancy way of writing the letter y. When we write equations, y equals something, f of x, g of x, h of x, f of t, whatever you see, if you ever see that relationship, that's just a fancy way of writing y. What it's telling you is what's coming after the equal sign meets the definition of a function. That's all it means. Okay? So this is not f times x. It is not g times x. It is not h times x. It's just a way we represent functions. Okay? Functions, graphically, I'm just going to graph this one, and I'll graph this one, and I'll graph this one. Okay, all three of these are relations. All three of these are somehow x is related to y. Okay? The two on the left are called functions. Visually, a function has to do something called pass a vertical line test. A vertical line test. And a vertical line test just means if I were pretending, here's my vertical line, and I go through anywhere along this graph, if this line only goes through the graph one time, it passes the test. Okay, do you see as I'm going from left to right? It's only passing one time, any point on that graph. Same here with this line. Anywhere I go with this line, going forever, it's only passing one time. Here, right there, it's passing two places, right? You see it? Okay, so this is not a function. It's still a relation, and it still exists. It's not that it's imaginary. It's just something you wouldn't be able to designate as a function. David?
It's also something that's it's just straight, it's an undefined slope.
Yeah.
That's all that.
And x equals graph, x equals 3, x equals 7, with an undefined slope will not pass the vertical line test because everywhere on that line, it's got different x values.
Got like a million points on that.
Yeah. Okay. So graphically, to tell whether it's a function or not, you can just do a vertical line test. You just take your pencil and move it over. Okay? When you're dealing with tables of values, what do you notice about, say, a point here and a point here? They both have the same what value? X. Okay? So if I have -1 in this case, mapped to two different values, that's the equivalent of having two different x values for 2 points, right? The same x value for 2 points. Can't have that. This is not going to be a function. If the x value is mapped to more than one number, that's not a function. It's okay if the y value, if I had 3, 2, 3, if the y value repeats twice, that's okay. Because think about y value repeating twice. If I graph this, -1, 3, 0, 2, 1, 3, that definitely passes the vertical line test. But if I graph this one, -1, 4, -1, 7, well, that's the equivalent of a vertical line, and it's definitely not going to pass the vertical line test because the vertical line is going to go through every point, right? So you see the difference in being able to just look at a table of values and say, if an x is mapped to more than one y, not a function. Vertical line test graphically, If it passes and only goes through one point, it's a function. If it goes through more than one, it's not a function. Okay, and all that means is we know that every x is mapped to every y. Or one x is mapped to one y, not more than one y. It's just a special relationship. Okay, when I'm given an equation, let's see if my board will decide to join us again. Before now, your equations, come on, line. Don't do this to me. Get me through the end of the period. Come on. Jeez Louise. Okay, if I'm given this equation, y equals 3x squared plus 2x minus 7, and I turn it into function notation, all I'm going to do is rewrite it like that. F of x and y are interchangeable. Okay, now in function notation, if I ask you what this is, all this is doing is saying everywhere there was an x, replace it with negative 3. Everywhere there was an x, replace it with negative 3. And then evaluate. That's what f of negative 3 means. And that's how you say it. F of x is how I say this. F of negative 3 is how I say this. And that's just what it means. You're replacing x with a number. In this case, negative 3. Okay? Now, how many of you are confused still on dependent and independent variables?
So what's the dependent and what's the...
Okay, so the way I remember dependent and independent, if I have an equation like this one, okay, I can choose any value I want in the world for x. And y depends on what I choose for x.
So the
Y is dependent on what I choose for x. So x is independent, meaning I'm independent to choose whatever number I want for x. And then whatever I choose for x, y depends on that. The y value depends on x.
I thought x was dependent because of fx.
Now f of x is y. So it's just saying y, the function depends on the value of x I put in, and y is dependent on that value. So that's how you remember x is always independent, y is your dependent variable. Okay, the last part of this section talked about domain. And domain is just a fancy way of saying what are all the possible x values in this function. Domain is a fancy way of saying x values in a function. Okay, so as an example, let's shoot this one up and let's go. Okay, so this function looks crazy because it's not continuous. That's okay. I always do my domain in interval notation and always from left to right. So I'm going to pretend when I'm looking at this graph that I'm coming at it from the left, from negative infinity, and I see that it's going to negative infinity, right? It's going forever in the negative direction. Okay? So my domain is going to start at negative infinity, and on the x-axis, I'm getting closer and closer and closer to this point. What is that point? 1, 2, 3, 4, negative 5. Do I include that point? No, because it's open. So I'm going to go to negative 5, parenthesis, union with, now I'm going to start at negative 3 bracket, and it's going to go to infinity. So you always read like you're looking at the graph, walking on the x-axis from the left all the way through it to the right. I always write it from left to right. And if I'm doing that, and I'm on the x-axis here, and I'm going out way to negative infinity on the x, it's going to start at negative infinity. It's going to stop at negative 5. It's going to pick back up at negative 3. And it's going to keep walking to infinity in the x direction. Domain is always the x direction, just the x. Range, which we'll get to later, is the y. So the range of this function goes from 1, every number between 1 and infinity will be on this function. But let's just focus on domain in this section. Domain is the x values.
We don't have to do
Not today. Okay? I don't think. It may ask for, I don't know if it asks for range or not. Range is the y values.
Yeah.
It does ask for range. Okay. So let's do this one. This is at 1, 0, 1. Okay, let's find the domain. As I approach this graph from the left, what's the furthest left number that's going to be on this graph?
Negative 3.
Furthest left. You see the arrow? Say that
So
again.
that'd be
Negative infinity. It's going on forever. Getting bigger and bigger, going on forever, right? So I have negative infinity. And it doesn't stop ever, and it keeps going on to the right. So there's my domain.
Big domain.
Lines are going to have this domain. Parabolas are going to have this domain. Absolute values are going to have this domain.
This is just a confusing thing.
Okay? Now, this is a parabola.
just like
It's a U. We're going to get into those. You're going to know them backwards and forwards by the time we're done in chapter 4. But for now, we're in 2. So what is the range? If the range is all possible y values of this graph, what is the range? What's the lowest? With the range, you're dealing with y values, and you always start low and go high. What's the lowest? Yes. And does it include 1?
Yes.
Yes. So my range is going to go from 1 in the positive direction to infinity. That's the range of this graph. From 1 to infinity. Okay, so domain, always think you're just dealing in x values. Range, you're dealing in y values. You with me? Okay, so understanding what a function is part of this lesson. Being able to look at a graph and see if it's a function. And then being able to look at a graph and identifying its domain and range. Those are the pieces of this section. I will be gone Monday, Tuesday. I'm sorry. Mrs. Fennell will be here. You are going to do lessons 6 and 7 Monday, Tuesday, but I will leave WebWork open until Wednesday night. That way, if you've got any questions in class Wednesday when I'm back, you'll still have an opportunity to ask them. Mrs. Fennell is going to play recordings of me teaching 2.6 and 2.7 from last year. So there may be extraneous stuff in there about dates and times that don't matter. Just ignore that. Just the content's what I want. So she'll play both of those videos so you'll get an idea of what 2.6 and 2.7 are about. And then I'll make sure the WebWork's open and CK12 are open. And I won't close them again until I get back so you have a chance to ask for help.
2.5?
Yeah, I'll do 5, 6, and 7. I'll leave it all open until Wednesday.
So wait, I'm doing this question where it asks if fx or f2 or f of x equals x2 minus x minus a. Find the following, and f of x plus a equals. So I put x
I'm
plus
on that
a
same problem.
to the or squared, and then minus x of a or x plus a minus
Oh,
a,
yeah.
and it says you can only raise a variable to the power of it in polynomial. I just
Hold on a sec. Let me stop this recording.